All right, guys. So, hey, this is a video of today's lesson, going over the unit circle. All right. Again, we're going to have a minor a quiz tomorrow on this stuff. So I want you guys to make sure you guys understand how the unit circle works. Okay. I went back, a couple things I went back over, and let me go back and explain this again with the reference angle. And I think you guys understand this part right here, but just want to go over it again. So as I said before, okay, 30 degrees, 45, and 6 degrees, these are called reference angles. They're in the first quadrant, okay? Now, every other angle around the unit circle is a multiple of these angles, okay? And so, give me a second. Okay, here we go. Okay. Where was I at? Yeah. So the reference angles, right? We call these primary angles are 30, 45, and 60. Every other angle around the unit circle is a multiple of these three angles. For instance, 1 degrees, right? That is five times 30 degrees, right? 5 times 30 degrees is 150 degrees. Okay. So we have, and then 45 degrees, 3 times 45 degrees is 135 degrees. So you can notice now, so as we go in a circle, right? That's why it's important to know these three angles first, because every other angle is a multiple of these. Now, having said that now, 30 degrees and 1 degrees. Okay? If you notice, all right, this is 30 degrees right here. 1 degrees, the distance from 150 to 180, right, that is also 30 degrees. So that's why we say that these two, they have the same reference angle, because the distance from the angle to the x-axis is 30 degrees, and from here, 150 to 180, it is 30 degrees. So they have the same reference angle. All right. 135, and 45 degrees. They have the same reference angle. Okay. The distance from 135 to 180 is 45 degrees. Same thing. And just like with 60 and different color, 60 and 120, they have the same reference angle. That means they're going to share some things in common. That's why I kind of stress that. And as you go around the circle now, right, you're going to find also that 30 degrees, 210 degrees and 330 degrees, they have the same reference angle. They all share things in common. Okay. And likewise, and I hope now you get the picture, right? So 225, right? 135 and 45 and 315. They are the same, have the same reference angle. All right, guys. Just want to make sure you see that. And we can keep on going around with 60. But I think you got a picture on that. Okay. Now we were looking at these triangles right here. The reason why I stress these because this is where we derive the x from. It's from these triangles we derive the x and y coordinates as we go around the circle. Okay, and so that's why I wanted to show you that. Okay, so I think by now, I hope you guys understand that, right? From this triangle, right, the 30, 60, 90 degree triangle, we find the sine and cosine from those triangles. And then the 45 triangle, we find the sine and cosine. Okay. I did not do the tangent, but tangent, right, I can do the tangent right here. Tangent of 30 degrees, right, is just opposite, right, opposite over adjacent. And that is equal to 1 over radical 3. But when you rationalize it now, right, it becomes square root of 3/3. Good. And the tangent of 60 degrees, okay, all right, is going to be 60 degrees is right here. So this opposite over adjacent, all right, that is just tangent of 60 degrees. That is just square root of 3/1. All right, okay. Now, what I was trying to show you guys is this. How we get the X and Y values. But I think I kind of lost me, guys, with that. Just remember that the X value, right? Let me erase this for a second. Where's my, just remember this. This is the ray. Okay, and this is a unit circle. Bam. Let me go back. Let's suppose, right, remember it's a unit circle. So the length of the radius is 1. All right, it is 1. The length of the radius is 1. That means that the length of the ray is also 1. Good. So when I create an angle now, say at pi over 60, I'm going to have at the end of the ray is a point. Oops. At the end of the ray is a point. That's where the ray ends. You're going to have an X and a Y right there. The issue is, how do we find X and Y? I'm just going to give the formula. The X, right, is equal, the X coordinate is equal to, X is equal to the cosine of angle. Whatever angle the ray stops at, that's the angle we're going to use. In this case, it's 30 degrees. The Y coordinate, right? I use the color. The Y coordinate is equal to the sine of the angle. So in this case, since we're at 30 degrees right here, I'm going to replace this with 30 degrees now. With 30, let's use 30. Okay, blue 30 right there, and 30. Okay, so that's the way I start with angle. The X value is just equal to cosine of the angle. Now we're go back and look at the triangle we did today. The cosine of 30 degrees is just the square root of 3/2. The sine of 30 degrees, the Y value is just 1/2. Okay. And as you go around the circle now, the angle is going to change, right? But the formula does not change. It is still X equals cosine and Y equals sine theta, sine. So if I move this ray now to another angle, say power 4, now the angle is 45. But the formula is still the same. The X, right? The X is going to equal to cosine of the angle, and Y is going to equal to the sine of the angle. Well, since we're at 45 degrees now, it's going to be cosine of 45 degrees and sine of 45 degrees. Go back and look at those two, the 45 triangle, and you will see that the cosine of 45 and the sine of 45 are the same. So the cosine of 45 is just, let me use this, it's a square root of 2/2, and the sine of 45 is just square root of 2/2. All right. Let me put this in red and blue. Square root 2/2, and blue is. All right. And we can keep on doing that now. Now, for this one, the angle is 60. So you see now the angle is going to change, but it's still the same formula. Right? So now, if I move this up just a little bit now, to 60 degrees, oops, I didn't do that. Okay, to 60 degrees now. Again, now the angle is 60. So I'm going to replace the find X and Y now. I'm just going to replace in the formula the angle. Maybe this is how I shall approach it in class today. I think I went a little bit too deep in the class. And so now this is 60 and this is 60. And if you look again, the triangle that you did, the cosine of 60. I think I made a mistake here. Yeah, yeah, this should not be. Guess I'm getting tired. I guess I'm just tired. This should be square 3/2, and sine of 30 degrees is what? Good. All right. So now the cosine of 60 degrees is going to be 1/2, and the sine of 60 is square 3/2. Good. Now, for 90 degrees, I was trying to show you guys so you don't have to remember some of the stuff you don't have to memorize. If you just know how to, oops, if you just know how the triangle works. That's what I was trying to have some of you guys understand. All right? At sine degrees, the ray is here. If you notice now, there's no more x distance, right? All you have is just a y. Right? If you look now, as we go around a circle, right? The x, if you draw a triangle, this distance right here, right? As you create triangle, as you go to circle, this distance keeps on shrinking, 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 right? I'm going to right? It keeps on shrinking as you approach 90 degrees. So you see, as you get to 90 degrees, right? There's no more x value. So at 90 degrees, right? Let's bring up to 90 degrees now. All right, oops. All right. So to get 90 degrees now, there's no more x value. So at this point, the x value is 0, and all you have is just the y value, which is just the length, the radius, the length of the ray, which is 1. And that's what works, guys. Okay. And again, the reason why I can stress the reference angle now, that's where it comes in. Because as you go around the circle now, right? 30 and 150, because they have the same reference angle, they're going to share the same points. The only thing that's going to change is the sign. So at pi over 6, at 30 degrees and 1 degrees, right? If we just copy these over here and put it at 150, what you're going to have is square root of 3/2 and 1/2. Okay? But now, think of the x and y axis. On this side of the x axis, x is negative, right? But the y is positive. So in the second quadrant now, all the x values are positive and the y values are negative. Come down here, you do the same thing. Oops, you do the same thing in this quadrant now, right? Let's look at this angle 225. This is the same as 45 degrees. All right, they have the same reference angle, so they're going to share the same xy. Well, what's going to change now is the sign. So at 225, if I copy this over now, I'm going to get square root of 2/2. That is the cosine, and the sine is the y value is square root of 2/2. In this quadrant now, in the third quadrant, both the x and the y values are negative, right? So put a negative there and a negative line. And so you can keep on going and fill out the rest. So in this quadrant, right, both the x and the y are negative. In the fourth quadrant now, right, the x value is positive, but the y value is negative. In the first quadrant, they're both positive. All right, guys, that's what I want to get. All right. Now, so I've seen all you gotta know is this. All you have to know is the first. If you did I erase this? Right. Oh, this one here. Right. All you have to know is 30 power 4. And power 4 is pretty easy. It's the same square root of 2. This one's pretty easy. All you gotta know is these 3 right here, and then you can fill out the rest of the unit circle. Okay. And then what I was going to have you guys do today, we run out of time, is to do these exercises. Where's it at? Did I miss the page? Oh, here. All right, do this right here. Okay, so when it comes to cosecant, remember it's a reciprocal. Cosecant, cosecant is just 1/sine. All right, so all you gotta do is find the sine of 120, right, and then flip it. All right, so the sine of 120, if you look at the unit circle, okay, the sine of 120 is, where's my use? Okay, did I fill it? Okay, it's not filling. But the sine of 120 is just, I'll just put it right now. Okay, is the square root of 3. I'm in the wrong color. I should use blue. It's square root of 3/2. Okay, and the cosine is just, that's red, right? But the x is going to be negative right here. Good. All right. So the sine of, I said the cosecant, right? And so let's go back here. Where's that? Oh, wait a second. It's the same. No, here. Come on. So, okay. So now we know this is going to equal to 1 over, right? 1 over what a sine of 60 of 120 degrees is square root of 3/2. But this, you know, you do the reciprocal, and that becomes 2 over radical 3. All right. But now, because the square root is in the bottom now, you got to rationalize it. And that gives you 2 radical 3/3. All right, nice. Okay, so that's so when you have a reciprocal, all you gotta do is find the primary trig function and then just do the reciprocal. All right. Um, we didn't do a negative pi before the negative. We'll talk about the negative angles tomorrow in class. All right, before we go into the minor grid. All right. So go ahead and fill this out. Hopefully you get to this evening so you have a better understanding. All right, guys. Good.